So I guess that's end of introduction to what's IoT. So the next thing is what do we have in our center? We came up with this center, I guess, 3 years ago, and we already built the tools and to build the application. So I guess we actually know, a lot in this IoT. So what kind of application we have? The first thing is we like to try out the smart home systems. So when we think about smart home, we first build our IoT gateway, because we might have a lot of home appliances need to be connect to each other. And I guess one way is, each home appliance actually can talk to the internet, talk to the cloud. As you can see, it's quite expensive, right? Because maybe each module need an narrowband IoT module so that they can connect to the internet and connect to the 4G and connecting to your smartphone. And I guess it's not a very good idea, because when you are in home, you want to control, indirectly, not directly, instead of, go through the cloud and sending the command to my coffee machine. So I guess our first thing is, can we build an IoT gateway? And actually, we build the IoT gateway first. And then if you have so many end devices you want to connect to the IoT gateway, I guess one thing is not everybody is computer science major, right? And even for us, it might be a little bit difficult to connect from one device to the IoT gateway. So that's why we actually came up with some very, we say critical PANs. That's called auto and secure connections. So suppose you have billion of devices. How can you configure billion device, right? It takes a longer time to do it, right? So the better way is, do we have a method that we can auto connect all these devices together? And then that's why we have some, we have a couple of PANs working on that. And I guess we got already, in Japan, in Taiwan, and in USA, in Europe, and mainland China, we all apply that PAN. And the PAN is some are approved. For example, Japan and Taiwan, they are approved this PAN already. And in USA is I guess we will get the PAN soon. So the first problem is, how do you connect all these IoT devices? As I was told that in Freescale, they have an IoT truck. They went all over the USA. They try to demonstrate what's IoT to the students, in USA. And they told me that when they, park in maybe some primary school or high school or maybe university, they take 2 hours to configure all these devices. So it's maybe not a good idea. Or for example, if your grandpa or your grandma, bought and buy an, home appliance, it will be very tedious for them to say how to connect. First do this and then that. I guess grandpa and grandma will not use it anymore, right? So that's why we came up with the solution. Okay, now I will tell you this later. So we solved the first problem is the smart appliance and end devices can automatically and secure connect to the IoT gateway. The second thing is, how do you control, your smart home, right? I guess everybody now have how do you control your smart home system? I guess smartphone is very important, because we can use visualize to take on the dashboard, or maybe we can use our voice, so that we build some technology like voice recognition, voice command, and then I guess you see our bottom board, right? Bottom board, you can Datum board is a project we are working on. So actually, you can talk to the boy, and they can do something.
Yeah, I haven't seen it, but Eren is working on it.
Actually, not.
No,
Eric
is working on it.
Yes. And they have they have expert system in some kinds of machine learning mechanism built inside it. So I guess a smart home is very important, and they have problems, when we automatically connect to the IoT gateway, but how does this device, show their functionality to your smartphone, right? We call it auto dashboard problem. How do you provide provisioning, the functionality to the device you want to control? And so either you can use maybe voice command, or maybe you just, tap, who you want to turn on the light by, click a button. So the second problem you need to solve is the dashboard problem. But before solving the dashboard problem, you must have a way to describe what the functionality, what resources you have for the end devices. The third problem is, maybe in home, then you can use smartphone or maybe any in-home display, or maybe just voice command to control all this stuff. However, when you are not at home, maybe you are in the office, or maybe you are on the road, you probably go to the cloud, right? You send a command to the cloud, or your smart home detects some abnormal situation. They send a message to the cloud and eventually go to your smartphones. So the fourth component is cloud. That's why our IoT system based on this one. We have real-time operating system on the end devices. We have IoT gateway, and we have a smartphone app, and we also build a cloud. That's our system.
Is the smartphone connected to the cloud or to the gateway?
Both.
Both?
When you are at home, your smart home automatically connect to the gateway.
Yes.
But when you are on the road, or maybe in the office, they connect to the cloud.
Okay, but when you are connected to the gateway, you can still access internet.
Sure, no problem.
Yeah. Okay.
So our technologies, we use like Raspberry Pi as the gateway. And when you turn on the gateway, they can automatically, start the auto and secure connection mechanism. Also, we have MQTT broker start on the gateway or automatically, and the co-app server. But we don't support DTS at the moment. And when you power on any of your end devices, it could be just like a sensor, or maybe your smart home appliance, like a smart coffee, and they can automatic, connect to the devices. The first thing is this one. And when they connect to the devices, they try to post all the resources to the gateway. What I mean resources is the input devices functionality and output device functionality. So input device functionality are a bunch of sensors, right? So you can say maybe it's too dark. How do you know it's too dark? You might have a photo sensor to do it, right? So if you have photo sensor, then you provide a sensor service to others, and anyone can read your information. And for example, in the smart coffee machine, in this machine we provide a couple of functionality. For example, you can set how many cup of coffee depend on how many guests to your home, right? And then when people come, you don't need to go to the kitchen. You just sit in the sofa, and then you say set 3 cups of coffee, something like that. And maybe you like to have strong coffee, or maybe have medium coffee or light coffee, and you can also set that. So they provide some actuator function for you too. So we say these are resources. They must be described in a certain way, so that all these end devices can be, when you connect to the gateway, and then gateway know how to control you, something like that. And the third thing is the gateway have to collect all the information to these connected devices. They make a list, what kinds of resources, what kinds of devices I have, and for each devices, what kinds of resources I can control or I can use it. So when you have smartphone, right? Smartphone actually have display. So when the smartphone automatically connect to your gateway, then they read the list of devices and read the resources of every devices, and then he know this smartphone app know how to what kinds of service you provide, so that they can automatically show the dashboard. A dashboard is some kinds of control panel. You can use it, right? So in this case, you can use the smart home appliance in your home. But however, you might want to connect to the cloud. For example, for a company, you might have a company in Paris, a company in Beijing, and maybe some company in Taipei. So in this way, you probably have many places you want to know all these sensor and actuators. So we use MQTT mechanism to send the information through the internet. So first is the gateway use MQTT. The MQTT can pass through the firewall so that they can reach the cloud. So that they will tell the cloud, what's my IP address, and what kinds of devices, connected devices, I have, so they can send to the clouds. So like your smartphone, in the cloud, they know a list of the devices, connected devices, but not just single site. Actually, you can have the other from Beijing and maybe the other from Paris, something like that. So you have all the information on your company, for the smart home, but for the company as well. And in this case, you don't need to use any app. You just use your browser. So it's browser based. So when you are, on the road, you can use smartphone because your phone have browser. Or you may use PC or any, connected devices to control your home, something like that. Or if there are something happen, they will show on your display, something like that. But you must be, for the browser, you must be able to, always receive it. So maybe it's not a good application. So that is our architecture to build in the smart home. And you have a question?
Yes, it's just I thought like co-op and MQTT were the same thing, like kind of the same. So what is the difference between MQTT and co-op?
MQTT is good for communication.
Yes. And
co-op is good, make your device as a server. And for communication, like here, I guess you have gateway, right? And you might have some kinds of firewall.
Yes.
Co-op cannot go through the firewall, but MQTT can.
Okay.
So that's why MQTT, maybe what I think is co-op is kind of a little bit local.
Yes.
Because it's a client server concepts. But things you want to go through the internet, you probably have some problem because when you try to connect to the internet, they might have firewall or whatever. If there is no firewall or other stuff to limit you, then co-op could be scaled to the internet without any problem. However, MQTT actually they come from the how should I say that? It is the you can send some IP first to this guy, right? Mm-hmm. So because the in this way, then it's legal always, because if you have a firewall here, then it's always legal.
Okay.
So this guy know your IP address. Things you send a message to me so that I can send back a message to you. But co-op is kind of you need to know I'm a co-op server here, right? and you need to know your IP address because it's server, right? Because for example, this guy is server, then I need to know your IP, then I use your service, right? Similarly, problem is here in the cloud. You don't know this guy, where this guy is. So that's why you use MQTT to send out all the information to the cloud.
Like, you mean like MQTT is more like UDP communication?
No, MQTT is TCP communication.
TCP?
And CoAP is UDP.
UDP, okay.
Right. Okay, we will go through that later.
Okay.
The MQTT and CoAP. And we have some other application for wireless charger. And wireless charger is our goal is to build 10,000 store like in 7-Eleven, in the library, in convenience store, or in the station. So everybody, if anyone want to charge their phone or charge their notebook, they can use it. Right? So the architecture is quite similar. Here we have IoT gateway, we have Internet gateway, and the wireless charger actually built inside the table. So they are not like in our lab. We have
just the bench,
right? But everything is built on the. You cannot see. It just embedded in your furniture.
Mm-hmm.
So here we just change the end devices, to the wireless charger. The whole architecture actually are quite similar. And here we have another pan is because you want to operate the commercial application 24/7, right?
Mm-hmm.
So we have some kinds of fault tolerance mechanism built inside the gateway. So if one gateway is out of order, the other can take over the whole things, and then so that the mechanism can come and fix it or maybe replace it, so that your business will not stop because the failure of gateway. And also we send all this information to the cloud, so you can see that where you have the device you can use. So for example, there are 8 companies working on this project, and one of them is called AnyCharge. They build app for iPhone, and you can just maybe download AnyCharge. And you can see that here in Taipei, we already built maybe more than thousands of it. So you will see a black one here, mean they are not available. Everything not available. Why? So let's see. So they will show you how to go to the charger.
Yeah,
and
we saw it in the maroon, like in blue it's available.
But I guess that they can also tell you how many devices you can use it. So for example, if I think the system is now functional where, because then you can see that none of the device can be used.
I think it was working on last Friday when we saw there was blue one.
Okay, yeah, blue one is some devices are available to be used. However, today none of them can be used. Let's check. In the Taichung, no, okay, something wrong. Yeah. So this is the app, and they can show you how to go to the wireless charger, and they will show you how many available wireless chargers can be used, something like that. Okay, so we use in the summer university last year, and actually the guy who in charge of this project, they try to build the whole system for Tokyo 2020 because more than dozens of millions people flying into Tokyo for the Olympic game, right? And I guess you battery, you need power, so they try to build it. But I guess I guess they still negotiate. And this is some smart data center we built for some big company in Taiwan. So what do they have is they have private data center. So they have two refrigerator actually not power on at the same time, because if it's too hot, they might harm the server and the hard disk. So that they actually if this is on, then this is off. Off means they only blow normal wind. They not a cool wind. Okay, so the cool wind is detected by first a speed meter to detect if the fan is working correctly or not. And the second is we put a temperature sensor beside it, so that we can also know the wind, the temperature of the cold wind or warm wind or something like that. So if this guy is on, and then all the information, the temperature and the humidity and the fan speed was corrected, so that you can say that maybe this fan is kinds of going down, because you can see the fluctuation. Or we also can detect the like this guy, you can detect how many power you consume. So if some kinds of fluctuation in your power usage, and that the machine need maintenance, something like that. And so this is the power measurement, what we call current detectors. It is 96 amperes, because they receive the city power, and the other is they receive the diesel engine in the basement. So when there is no power from the city, then they would automatically turn on the diesel power generator. But we detect 2 times that although the diesel power generator is turned on, but actually the power does not go through the data centers. Then we sound alarm immediately to them, and they fix the problem. And we have also smart plug. I guess you saw that before, right? And this smart plug can also measure how many energy you consume. For example, you put the air conditioner with it, and then you can measure how many power. When we say smart meter, that's for a home or for a factory or factories. But if you want to measure the local, you want to measure some appliance power consumption, then you need to use our smart plugs to do it. And this is the temperature and humidity sensor. And then we have detect because this air conditioner might leaking some water, so we detect if some water is leaking, and if anything is in abnormal, then we send show message or send email or send line to the administrator, something like that. And this is the the on-site testing. So we have 2 meters, wind speed meter, and we have 2 temperature sensor put inside it. And because the room is in the higher floor, so you can see that the sunlight is quite strong. So in some close to the windows, we also put the temperature sensor to make sure that everywhere are cool enough. And this is the on-site testing. Maybe I can. So because I'm recording, so